Perform a first derivative test on the function f of x equals 2x cubed plus 9x squared minus 108x plus 7 on the interval, closed interval, -6 to 8. Locate the critical points of the given function. Use the first derivative test to locate the local max and min values. Identify the absolute min and max of the function if they exist. And find the concavity and inflection points of f of x on the interval -infinity to infinity. Okay, so the first thing we want to do is take the derivative of the function. Okay, so I'll write the function down here again, since it split lines there. And that is on the interval -6 to 8. That's a closed interval. Okay, so f prime of x, take the derivative term by term here, gives us 6x squared plus 18x minus 108. Okay, so in order to find the critical numbers or the critical points of a given function, we have to set the derivative equal to 0 and find either where f prime of c is 0 or f prime of c is undefined. Okay, since this is a polynomial function, we're not going to find a place where f prime of c is undefined. But we could definitely find some places, one or two places where it's equal to 0. Okay, so let's set this equal to 0. 6x squared plus 18x minus 108 equals 0. We can factor out a 6. If we factor out a 6, that leaves us with x squared plus 3x plus 18 equals 0. And then that factors into 6 times x plus 6, x minus 3. That gives us two solutions. X is equal to -6 and x is equal to 3. That's when you set these each individual term equal to 0 right here. It gives us two solutions there. Okay. All right. So those are apparently our critical numbers, except that we do have an interval. Okay. And keep in mind that your endpoints when you take the derivative becomes an open interval, not a closed interval. So if f of x is closed on the interval -6 to 8, it is open on the interval exists from -6 to 8 on an open interval. Okay, so we're not going to include those endpoints. Okay, and you notice that one of these is actually one of those endpoints. So when you're looking for absolute extrema or such, you can use the endpoints, but in this case we're looking for critical numbers that exist on the interval, so we're going to throw out that endpoint. We're just going to use 3. So 3 is our critical number, our critical x value. If you wanted to find the critical point, now be very careful when they ask you for critical numbers versus critical points. Critical numbers, you can just say x equals 3. That's your solution. Critical points are a little different. A point is an x and a y value. So if you want to find the point, you're going to need to plug in f of 3. Okay, so 2 times 3 cubed, plus 9 times 3 squared minus 108 times 3 plus 7. Okay, so we can type that into our calculator. What I'm going to do is just go ahead and plug it into the calculator here. So in the graph part, 2x cubed plus 9x squared minus 108x plus 7. Okay, so there's a few ways, or a couple of ways that you can find the values now that you have it typed into the calculator. You can go to second window and tell your independent variable to ask. That way when you hit second graph, you have a blank table and you can type in what you want. And what number do we want? 3. Okay, so -182. Okay, another way of doing it, since you have the function typed in, hit vars, go over to y vars and hit enter on function and enter on y1, open parentheses and type in 3 and hit enter. It also gives you the function value that you have typed in y1 in the graph if you plug in a 3. So the critical point of this is 3, -182. Okay, that takes care of A. B. Okay, for B it says use the first derivative test to locate the local max and min values. Okay, so we know that the local max and min values must exist on the interval. Okay, so we're testing whether or not this right here is a local minimum or a local maximum, because it's our only critical number. Okay, so what we need to do is set up a line, a number line here, and put 3 in the middle, since x equals 3 is our critical number. We're going to test f prime of x, and then we're going to say what f of x is doing. Okay, so we're going to plug in some numbers into the f prime of x function, and these numbers cannot be 3. They have to either be to the left of 3 or to the right of 3. So you can choose any number to the left of 3, just a number that seems easy to use. And I think that trying x is equal to 0 is a pretty easy number to use. Now keep in mind, you still do have to keep within this interval right here, -6 to 8. Okay, and on the right side, what's an easy number to try? Well, I mean, I guess 4, 5, whatever. I'll do 4. Okay, so if we try x equals 0, remember this right here is our function. Before, we didn't divide or anything, it's just been factored. Okay, so this is the derivative, but we worked on it and got it down to this point right here. This is the easiest point to plug in numbers, because it's all factored for you. Okay, so you plug in a 0, so f prime of 0 is equal to 6 times 0 plus 6 times 0 minus 3. You don't really care about the answer here. What you care about is if this is positive or negative. Okay, so we've got a positive, this is positive, and this is negative. So positive times a negative is a negative. Okay, so we know this is minus, that's a negative. Okay, and what does that say about the function? If the derivative is negative, what does that say that the original function is doing? Well, remember, the derivatives are talking about slope. Okay, so they're saying the slope of the function is negative. If the slope of the function is negative, then as you're traveling left to right, it's going down. Okay, so over here, f of x is decreasing. Okay, now let's try x equals 4. So f prime of 4 is equal to 6 times 4 plus 6 times 4 minus 3. And again, we don't care about the actual answer. We only care if it's positive or negative. Positive for the 6. This would be a 10, so that's positive. This would be a 1, so that's positive. So it's positive, 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 which means it's positive. Okay, so f prime of x is positive, which means the function itself, the slope, is positive. It's going up. Okay, so this is increasing. Okay, so if before 3 it's decreasing and after 3 it's increasing, what does that mean? Okay, well, let's take a look at what that might look like. So decreasing, get to the point, 3, and then increasing again. So what does that make x equals 3? Is that a minimum or a maximum? Okay, well, we know since it's decreasing and increasing, this is a minimum. So this is a local min, 3. Okay. All right, let's go on to the next question. It says, identify the absolute min and max of the function if they exist. Okay, this is where we'll use those endpoints. Okay, so we know that we have our critical number. Our critical number is x equals 3. Okay, but when you're looking at absolute minimums and absolute maximums, you also have to try the endpoints. Endpoints can possibly be an absolute minimum or an absolute maximum. So our endpoints would be x is equal to, what was the interval? -6 and 8. Okay, sorry, my writing's getting kind of atrocious there. So our endpoints are -6 and 8, and our critical number is 3. We need to plug all of these into where to see if they are the absolute min and max of this function. Do we plug them into the original function or the derivative? Well, if we're trying to see where the function is biggest, that's maximum, and where it's smallest, that's minimum, we're plugging into the actual function. Okay, so we're going to plug in f of 3 and get an answer. We're going to plug in f of -6 and get an answer, and then we're going to plug in 8 and get an answer. And luckily for us, we've already typed this in the calculator. Okay, so I don't know which way you guys prefer. I'm going to use the vars way. We've already typed in the 3. Okay, so we know that that answer is -182. Okay, vars, y vars, function of -6. Okay, 547. Okay, and then we've got, let me make sure I got that function typed in right. I never actually looked. Yeah, okay. And then we've got vars, y vars, enter on 8. Okay, so we've got 743. Okay, so the absolute min and max are pretty easy. You just look for the smallest number and the biggest number. So this x is equal to 3 is where the absolute min occurs, and the absolute min is equals negative 182. Whoops, sorry, running out of room here. Negative 182, and it occurs at x is equal to 3. Okay, absolute min is negative 182, and it occurs at x is equal to negative 3. And now look at these two. This one's gone. This one is the one we want for max. So the absolute max is equal to 743, and it occurs at x is equal to 8. All right, now for the last question. Find the concavity and inflection points of f of x on the interval negative infinity to infinity. So we're no longer using those endpoints of negative 6 to 8. This is saying just find the concavity of this thing. Okay, so to find the concavity, we're going to need to take a second derivative. We've got the first derivative. Let's see, we've got the first derivative right there. So let's take the derivative of that. So f double prime of x is equal to, all right, term by term, this would be 12x plus 18. Okay, so that's the second derivative. Now we set that equal to 0 and solved. So x plus 18 is equal to 0. X is equal to negative 18 over 12, which is equal to negative 3 over 2. Okay, so that tells us our possible point of inflection. This is a PPOI, possible point of inflection. It's not necessarily a point of inflection, just possibly. So to figure out if it is a point of inflection, again, we need to draw a number line, and we put x is equal to negative 3 over 2 in it. We're going to look at f double prime of x, and then we're going to say, what is f of x doing? Well, f double prime of x is doing something else. So again, we will try some numbers to the left, we'll try some numbers to the right. So to the left of negative 3 over 2, the easiest number I can think of is x is equal to negative 2. And to the right, and remember this is just try, these numbers don't mean anything. You can pick any number. You could pick negative 200 here if you wanted, because we're on the open interval negative infinity to infinity. So anything to the left of negative 3 over 2 you can pick, and it should give you the same answer, whether positive or negative. Not the same answer, but the same sign of an answer. And any number to the right. So you could choose 0, you choose 1, 2, 3. So let's just try 0, because obviously that's usually the easiest one to try. Okay, so we plug into the second derivative, negative 2. That gives us 12 times negative 2 plus 18. That's negative 24 plus 18, which gives us negative 6. That tells us that the second derivative is negative there. Okay, so if the second derivative is negative there, that means that the original function is concave down. Okay, and then if we go over here to the right side, if we try 0, f double prime of 0 equals 12 times 0 plus 18. Obviously that is positive because it's 18, so this means that it's concave up. Okay, so since the concavity changes, we go from concave down to concave up, then we do have a point of inflection. We have an inflection point. Let's write that down. Inflection point at x is equal to negative 3 over 2. You could get the y value if you wanted to go with that. I'm not going to do that this time, but if they actually ask for a point, you need to plug this into the original function and get the y value that goes with it. And for concavity, we've got concave down on the interval. Well, let's see. We go from negative infinity to negative 3 over 2. Do I include that with a bracket, or do I do a parentheses? Well, it's neither concave up or concave down right there at that point. That's where it changes concavity, so you can't include it. And then concave up on the interval negative 3 over 2 to infinity. And that's it.